now that we're all done with our east side windows, why don't we turn our attention to the south, which is certainly, of all of our elevations, the most complex. So let's take a look at the south-facing windows. Let me go to my drawing set here and scroll down to the south face, and let's take a look at what we have here for our windows and doors and what we're going to need to do for shading. So we've got a couple of things happening here. We've got some sort of typical windows. On the left, south window 1-1 and south window 2-1. On the left-hand side there are sort of normal condition. We've got some mulled windows on the far right, and then in the center we've got some oddball pieces there. We've got our sliding doors with some shading over them, some horizontal shading over them, and then we've got our triple mulled fixed units on the top, and then we've got our eave overhang to contend with as well. So quite a bit of moving parts on the south side here. But we're just gonna move through it in exactly the same sort of fashion. We use all the same tools and the same process that we use on everything else. I mean, there's more here, but none of it is significantly different than anything we've seen so far. So we'll just move through it one piece at a time. So let me zoom in a little bit here, and let's see if we can go. Let's see. We'll just start on the lower left and work our way left to right, bottom to top. So let's start with south window 1-1, and so this is a typical tilt turn window install, and so it's going to have all the normal details for the jamb and the head, etc. So let's come into our PHPP, and I'm going to scroll back to the left-hand side here. So scroll down a little bit to our south windows. So we've got our south windows. So south window 1-1 on my PHPP on row 28. Now, first thing we encounter, horizon shading. Do we have any horizon shading? No, we do not. If we were to go back to our site plan, we would see there are no known shading objects out to the south, no trees, no buildings, no neighbors, nothing like that to contend ourselves with. So we can leave horizon shading blank for now. If we did want to propose planting trees or something like that, we could come in and experiment with some values there, but we're going to leave it blank. This building's out in the middle of a field, so we don't have any inputs there. All right, so we start with lateral reveal as always, and lateral reveal here is much more straightforward. Of course, the window reveal depth is 5 inches, so I'm going to put in 5 here as usual. And then the distance from the edge of the glazing over to the cladding, as in all of our other cases, is 0.6. Are all of our typical cases. So a typical non-mulled normal install uses that 0.6 value. Okay, and what about the reveal overhang? Well, this is another one of those cases where we don't know whether the more shading option is the self-shading from the wall, or the fact that we have a roof eave up here over the top of the window. So let's first of all see what we get when we calculate the self-shading from just the wall. So for instance, if I put in 5 as the back set, and then 0.6 as the vertical distance, let's see what I get for a total shading factor. So for the overhang shading factor for south window 1-1, I get a 96% reduction factor when taking into account just the shading from the wall itself. So now let's change those values. Let's input the values for the roof overhang and see if it gets higher or lower. So let me go back to my overhang, the same way we did this on the north side. So I want to modify those two values so that my vertical distance goes to 10 foot 10. Notice we're measuring from the top edge of the glazing all the way to the bottom edge of the shading object, in this case the eave being the shading object. And then what's my back set going to be? How far, what is the dimension from the pane of glass out to this leading edge of the shading here? Well, we can go to our section view, and just like on the north side, because it is a symmetrical building, we see that all the windows are installed in the same place, so we have a 2-foot dimension from the pane of glass out to the leading edge of that shading object. So 24 inches horizontal, and in this case we were saying 10 foot 10 as the vertical dimension. Let me go back here so we can see that. All right, so we're going to change those two dimensions, and just to remind ourselves what's the number we want to beat, we're looking to see if we are more or less shaded than 96%. So I'll put in those two values here. So the overhang depth is going to be 24 inches, 2 feet. And then the vertical dimension is 10 times 12, so 10 feet, plus 10 inches, or excuse me, 10 feet times 12, so 120 inches, plus 10 inches, 10 foot 10, so equal, enter 130 inches, so 130 inches up and 24 inches out. And remember, 96% was our number to beat. 97%. So what does that mean? Remember, lower values are more shaded. Lower values are lower or less solar radiation reaching the window. So in this case, 96% is actually the more significant shading for us to keep in mind or enter here. So I'm going to go back and I'm going to reset these. I'm going to set these back to 5 and 0.6. And now if I come to the right-hand side, you'll see that I'm back to 96%. Okay, so this is, again, very common for this type of thing. The only way that we know is to model it and try it. See what the answer is, and then that whichever one gives us the more significant shading, that's the one that we're supposed to use in our model. Okay. Let's do this. Let's skip over the south doors for a moment. We'll come back to them, obviously, but let's see if we can finish up our sort of normal windows all in one video here. See if we can kind of move through this a little more expeditiously. Try not to drag this out too long. So there's our south window 1-1. I'm going to skip over south doors for now. We'll come back and address those in a later video. But let's shift over here to south windows 1-2 and 1-3. Now, south windows 1, 2, and 1, 3, this is another mulled condition. So here's another mullion case. So we could go off and do our drawing, same as we did for the east side. However, if you look at the dimensions here, 2'7" wide, 4'9" tall, and you look at the east side, 2'7" wide and 4'9" tall, we've already done all this math. We already know what those numbers are. So I can just take the same numbers that I got from my east side and copy them over and reuse them for south windows 1-2 and south windows 1-3. Right? So if I scroll up a little bit and I take a look at my east window, which ones were the ones? East window 1-1 and east window 1-2. Right, these were the values that we already calculated. So I can just come in here and I can say copy, and then I can come down here to south window 1-2, and I can say paste. I'm going to say paste special values, just to show again. I right click and say copy. I'll come down here to south window 1-2. I'll right click and say paste special, and I'm going to paste just the values. I don't want to copy the formatting or anything like that, and I can paste that information in. Oops, like I say, copy. Let's try and do all of them. There we go. And there we go. So all of those values can get copied and pasted down. Right, and the only reason, to be clear, the only reason I can do that is because the windows are exactly the same size. They're all 2'7" wide by 4'9" tall. So those values are going to be identical. When we could draw it out, but we would get the same result. And obviously, I can do the same thing over here. I can say copy the top, the overhang, and say paste special values. There we go. So there's our south window 1-2 and 1-3. Much easier because, again, they're the same numbers, the same values that we had before. Okay, so hopefully that makes sense. Let's go up to the second floor now. We have another easy one, south window 2.1. So south window 2.1, that one is going to have the normal 5-inch backset, of course, and then the normal 0.6 side reveal dimension, right? So that's just a single window, unmulled. Now, of course, the overhang dimension is going to be a little bit different. In this case, we can start by saying 5 and 0.6, and we'll come over here and we'll see that the overhang, in this case, the overhang is giving us a reduction factor of 92%. And but what we do want to do is we want to check this against the eave as well. This one is much closer to that roof eave, that roof overhang, and so this one is it's more likely that this one is going to see more significant shading from that roof overhang. So in this case, let's put in an overhang a depth of 24 inches and then a vertical distance here of 2'4". So 28 inches. Whoops. So let's change that. So overhang depth, we'll change that to 24, and then we'll change this to 28, 2'4". And let's see what we get for a calculated reduction factor. And notice in this case, we get a calculated reduction factor of 88% thanks to the roof overhang. 88 is obviously lower than 92%, which is what we got before. And so therefore, the roof overhang in this case is the more significant shading object. And that's because this window is much closer to the roof overhang than the ones down on the first floor. So hopefully that makes sense. Now again, let's maybe skip over, let's skip over these guys for a second, south window 2.2, 2.3, and 2.4, and let's skip over and go to south windows 2.5 and 2.6. Again, these are sort of normal windows. Notice they are both 2.7 and 2.7, so same width as before. So in fact, we can use the same lateral reveal information here from 1.2 and 1.3, 1.2 and 1.3. So I can grab that, say copy, and then I'll go to south window 2.5 and 2.6, say paste, and there we go. Right. Again, the only reason I can do that is because these horizontal dimensions are identical in all these cases, so I can just reuse that same calculation. And the other thing I know, because I just did it for south window 2.1, is that this is the information we want to use for our overhang. So I'll go ahead and paste that in as well. And bam, there we go. So there's all our quote unquote normal windows, right? So there's all our normal windows. We're kind of reusing a lot of pieces we've already calculated. We could, of course, go off and draw all of this explicitly and strike all these dimensions explicitly if we didn't want to kind of keep track and reuse things. That would be totally fine. But just to kind of speed things up, we can do it that way. Let's take a look now at these this triple mulled unit. Now this is a case we have not encountered yet, so I do think we're going to have to draw this one. So let's go ahead and draw this one together, and let's see what that results in. So let me go back to my SketchUp view here. Pull that out a little bit. Go back to the SketchUp view here. So what do we have? We've got 3 of them at 4 foot by 4 foot. So we've got 4 foot by 4 foot squares. And we've got 3 of them. So I'm just going to draw out the windows, same as we have before. Again, you could be doing this on pencil and paper. You could do this in CAD. You could do this in Bluebeam. You could do this in Rhino. You could do this in whatever your program of choice is. All right, and as before, what we want to do is we want to draw out our frames. So 92 millimeters, that'll be our left edge. And then we've got 92 millimeters. That'll be our right edge, and we're going to have 92 millimeters on the top, and we're going to have 92 millimeters on the bottom. I don't really need to draw that. Obviously, the bottom doesn't play into our shading calculation, but just for, keep everything nice. All right, and we are also going to want to draw in our mullions here. So I'll come over and grab these guys, move them over 51 millimeters, and I'll do the same thing the other direction. Try and select all these. Oops. Try and select the right. Oh boy, now I've done it. Trying to select the right ones here. There we go. And I'll pull these guys over 51 millimeters, and there we go. So we've got our 3 panes of glass, and then we've got all of our frame elements there. And clean up here just to keep everything make it obvious what's what. Let me just go ahead and erase all these stray edges here, just using the little eraser tool. Again, use whatever program you like to do this kind of drafting or quick sketching. Again, doing it on pencil and paper is just fine. If I could figure out a way to put pencil and paper on the screen, I would, but okay. So there we go. So there's our 3 windows there. And then the other thing that we want to do is we want to draw our cladding. Oops, let me do it this way. Let me do it like this, and like that. All right, right. So there's our cladding edge, but of course it's not perfectly aligned with our window. It is in fact 15 millimeters or 0.6 inches off the face of our glass there. So I'll pull these over 15 millimeters. I'm just typing in that dimension there so that it's all dimensionally accurate, and then we do the same thing on the top, although again we already know the number there. Okay, so there is our situation. So that's kind of a different one to be sure. So let's start with south window 2, 2. So the lateral reveal, again, we want to calculate the average. So I want to calculate this dimension. Then I want to go from here all the way over to the cladding and then just get the average. So I'm going to take this dimension first. Oops. And let me see if I can turn this detail down a little bit. I don't think we don't need that many. Let's do it to that. Let's see if does that change it? Didn't seem to change anything. I don't know. However, to set those snap settings there, or those, there's got to be a way. I probably shouldn't be doing this on the video. You guys don't need to see this. I guess that's where I would do it. I don't know what I set down here. Enable length snapping to whatever that is. There we go. 95 inches, 0.6 inches. Better. All right, so 95 plus 0.6 divided by 2, right? We've got 95 inches on this side, 0.6 inches on this side, and then we want the average of those two. So south window 2, 2, it's going to be 5 inches backset, of course, and then it's going to be 95 plus 0.6 divided by 2. Did that wrong. 95 plus 0.6 divided by 2, right? That's just our average of those dimensions. And what about our top? What about our head detail here? Well, our head detail, we are told, so notice this one is actually mounted at a slightly different place. So we are 2'1" from the bottom of the eave to the top of the glazing there. So we are going to be 24 inches in depth for our vertical overhang, but we're only 25 inches in the vertical dimension there. So I'm just taking that dimension right off the page here. Okay, fine. So what about 2, 3? Let's do 2, 3. Well, 2, 3 is the middle one here. And so let's just do our dimensions again. We'll do this dimension here. So 47, and of course this dimension here will be identical because it is symmetrical, so 47, 47. So we know the answer is 47, but just to be clear, we're going to take the average. So 47 plus 47 divided by 2 will give you 47. And then, of course, it's in the exact same position vertically, so I can just propagate these down, 24 and 25. So 24 inches in backset, and 25 inches vertically, 2'1" right here. Okay, and then lastly, south window 2.4. What's that one going to be? Well, it's going to be the same as south window 2.2 because, of course, this whole thing is symmetrical, but we can go ahead and prove that by just grabbing these dimensions here, 95 and 0.6, 0.6, and 95. So we can do that. 5 inches backset equals 95 plus 0.6 divided by 2 should give me 47.8. 47.8, just like this one here. And of course, it's going to be in the same vertical position, so we can just propagate that down. And there we have it. So we have all of our window shading completed for the south facade at this point. So when we come back in the next video, we'll turn our attention to those big lift and slide doors. Those are going to be kind of a unique case. So we'll go ahead and take a look at those pretty carefully. So I'll see you back in the next video, and we'll take a look at those doors.